Hi everyone, this is Poojitha from Sri Venkateshwara College of Engineering, Department of CSE AI. Today let us see about text search, that is nothing but NFA and DFA, in the subject Theory of Competition, that is nothing but TOC. Now let us see Introduction to the text search. Text search is a fundamental operation in computer science enabling efficient retrieval of information. It involves matching a pattern against a text string to find occurrences. Understanding how automata like NFA and DFA can optimize this process is crucial. Now let us see what is NFA. NFA stands for non-deterministic finite automata, that is nothing but NFA is a theoretical model used in a computational theory. An NFA can have multiple transitions for the same input symbol, allowing for multiple potential states. This flexibility makes NFAs powerful for describing various types of patterns in text searching. Non-deterministic finite automata is nothing but in NFA, given the current state, there could be a multiple next states. The next state may be chosen at random, and random next states may be chosen in parallel. Is an example. Now let us see what is DFA. DFA stands for Deterministic Finite Automata, is another theoretical model that processes input strings. Unlike NFS, DFS have a single transition for each input symbol, leading to a unique state for any input. This predictable allows DFS to be more efficient in executing but requires more memory for complex patterns. You can see an example in this image. Now let us see what is NFA versus DFA. NFA can be easier to construct for complex patterns due to their non-deterministic nature. DFAs, on the other hand, provide faster execution times since they do not need to backtrack. The choice between using an NFA and DFA often depends on the specific requirements of the text search application. NFA versus DFA, deterministic finite automata, characterized as 5 tuples. They are S, A, T, S naught and F. S is a set of states, A is the alphabet, T is the transition function, and S A X is nothing but stands for S. S naught is the start state, F is the set of accepting states. Non-deterministic finite automata, characterized as 5 tuples. They are also same, S A T, S naught and F. S is the set of states, A is the alphabet, T is the transition function, and S into A union of stands for PS. S naught is the start state and F is the set of the accepting states. Now let us see about conversion from NFA to DFA. Converting an NFA to a DFA is a standard process known as the subset construction algorithm. This process may lead to an exponential increase in the number of states in the DFA. However, the resulting DFA can execute searches in linear time relative to the size of the input. NFA to DFA, you can see example in this image. Now let us see text search algorithm with NFA. A typical text search algorithm using an NFA involves simulating all possible states transactions. As each character in the next is read, the NFA may branch into multiple states. If the NFA reaches an accepting state after consuming the entire input, a match is found. Now let us see about text search algorithm with DFA. In contrast, a DFA processes the input string character by character following a single path. The current state is determined slowly by the previous state and the correct input character. This characteristic leads to efficient searching, particularly for the large text. Now let us see what are the applications of NFA and DFA in text search. Applications. NFS and DFS are widely used in various applications including search engines and the text editors. They underpin the functionality of regular expression engines, providing powerful pattern matching. Understanding their machines allows developers to optimize text processing tasks effectively. Organization of programming languages, finite automata, NFAs to DFAs. Now let us see what are the performance considerations. The performance of NFA and DFA implementations can vary based on the complexity of the pattern. While NFAs may require less memory for pattern representation, their execution can be slower. DFAs are generally faster but can consume more memory, leading to trade-offs in design choices. Now let us see the conclusion of our topic, that is NFA and DFA. In summary, both NFA and DFA play crucial roles in the field of text search. The choice between them should be guided by the specific needs of the application, such as speed or memory efficiency. Mastering these concepts enhances the ability to implement effective text search algorithms. NFA versus DFA. DFA. For every state Q in S and every character alpha in alpha, one and only one transition of the following form occurs. NFA. For every state Q in S and every character alpha, one or both of the following will be happening. That is nothing but no transaction occurs, one or more transactions will occur.